I met Sanford Kwinter over 10 years ago. During our brief and unexpected conversation, we discussed many topics that seemed to make perfect sense, all together, only at that time. We spoke about whether or not men should eat animals, how contemporary architecture seemed to have a predilection for mimicking cobra skins. He touched upon evolutionary models and Foucault. He knew Umberto Eco and Bruno Zevi, and he smoothly swapped between English, Italian, and French. At first glance, he did not come across as an intellectual whose occupation was endless hours of reading and writing. He looked like he would belong more to a music scene or a science lab rather than architectural academia. But one thing was clear. 1 minute into our conversation, I knew that he had a truly wide-range vision. And probably, he was one of those people who cannot stop thinking. Surprisingly, talking for him was not about making a point. Embracing the scale and complexity of the historical forces he had in play in his doctrine was simultaneously fluid and challenging. What was assertive and clear one moment would unexpectedly become questionable along the way. As a result, one cannot always follow him. One cannot always agree with him. In the early 90s, Sanford Kwinter emerged as a leading voice on the international scene. His column for any magazine, called Far From Equilibrium, was breaking down belief systems rather than building them. The title was already an indication for the readers that his essays were speculative, in the sense that they pushed you to think not just about architecture, but the world, and the way the world works, but most importantly, the way in which designers work. The central concern of his writing was the art of technology and its social effects. At a time in which software and protocols were increasingly surpassing physical space, Kwinter outlined and sometimes warned us about the consequences of the emerging new media. Back then, his teaching, lecturing, writing, and publishing started influencing contemporary architecture in profound ways, because his column did not talk about architecture from the distant detachment of the pure theorist. He engaged, I would say challenged designers, building bridges among different disciplines. His teaching strived to reshape blocks of knowledge and put them in a relationship to one another so that knowledge could actually flow. In his writing, he used a mysterious we. He made us all part of a group of people, of a front of voices, of a pact. He implied that one's work and one's existence are potential agents of historical transformation. 15 years ago was a time when architects started experimenting, when they did not feel compelled to summarize all truth in architecture. And so were his books, Architectures of Time, Mutations, Far From Equilibrium, Requiem for the City at the Turn of the Millennium. All of his writing show a deep and frank interest in the relationship between culture, science, communication, technology, and design. In other words, they expand the range of architecture. Sure that his lecture tonight will widen the scope, responsibility, and ultimately freedom of design, please join me in welcoming Sanford Kwinter to SCI-Arc.
Thank you, Elena. Thank you, everybody. Thanks for the invitation. I taught here 2 years ago, 3 years ago, I'm not sure exactly, it was the summer, when the place was half deserted, and I didn't even know what the lecture hall looked like. Is this the lecture hall? Yes, well, now I do know what it looks like. The course, anything I need to remember? No, okay. I'm actually trying to remember my lecture. The course I taught here must have perplexed, especially the administrators, because I believe I was invited to teach in the section that dealt with, I'm not sure exactly what it is. I thought of it as essentially dealing with communications. And the course I taught essentially was on plant and animal communication, or the origins of communication. In some ways, the biology of communication. Now that is, in very precise ways what I'm probably going to talk about today. I say this because I have a kind of a basic lecture, and I fell asleep just before coming here during that precious time when I was going to figure out how to spin the lecture to match the title that you see up here. I know what I mean, and I'm going to figure out on the run how to get there. Oh boy, that's the light I've got, huh? Fascinating. Okay, a couple of things I'd like to say before I begin. One is to apologize to you in advance for a very long lecture. How long? Jeff, take a bath, man. And if you want to come in your robe, that's okay too. Don't insist that you stay, though I will tell you this. Those who do, and I'm not really trying to convince you to stay, because really that's really up to me and what I can do to keep you here with jokes and other things along the way, is that there's a nice little treat at the end. At least I find it a treat. Every time I see what I'm going to show you, I get really happy. So you're not leaving here sad. You may be fed up, but you won't be sad. And the second thing I want to say is that I have to do this because I'm highly oppressed for a very long time with something extremely beautiful, and that is a big exhibition that we are mounting and opening Friday at Harvard, which is, it's called The Divine Comedy. There are three very large parts to it. As you can see here, one very large installation by Ai Weiwei, another by Olafur Eliasson, and the other by Thomas Saraceno, who will float cities above the Carpenter Center. We'll see if that works. But the Weiwei is the one I want primarily simply to mention now. Many of you who've been watching the press, the New York Times, et cetera, know that Weiwei was incarcerated in the Beijing airport 2 days ago, and they pulled the plug on his studio. They've arrested everybody in the studio, and they've not been seen since, despite the State Department's, the U.S. State Department's request that he be released. This is part of a wide crackdown that's been taking place in China over the last several weeks, in which pro-democracy bloggers and others are being rounded up. And one particularly well-known one in the Sichuan province was sentenced just to 10 years in jail. So. Despite Weiwei's renown, and despite the coverage that his particular arrest and incarceration are taking place, despite the coverage that it has, it seems to me, based on the piece that was just released by the New York Times about 2 hours ago, it seems that no one is really fully confident that he'll be released anytime soon. That is it. Nonetheless, we're opening the exhibition, and I'm frankly hoping for some public response to the events of the last few days. So there we go. This is your brain on design. I think I've said my rejoinder. Let me get into it, because let's face it, we got to get out of here and get to dinner tonight. A couple of things I wanted to say as well. Listening to Elena, I didn't know who she was talking about, to tell you the truth, as I was listening to that introduction. I really didn't. I thought, little by little, I heard my name. I said, "Oh God, that's me. That's fascinating." But her focus on a few things was very interesting. I just wanted to say. Number one, that the focus on communication, which I never really thought of, in fact, is one that is, yes, it's one that I would like to have you explicitly aware of tonight. The other is that the way Elena depicted at least my work as a writer and theorist in the 1990s, focusing on technology specifically, and the general transformations in culture and in fact, in cities, et cetera, was one part of it. I want to remind you, and I say this, remind you is actually to tell you this, because nobody's reminded of anything these days, given the historical and intellectual record, is that it's basically it didn't happen. The 90s as if it didn't happen. And what I want to focus you on right now is that there was a great interest in certain philosophers, and especially in certain new developments in science that took place in the 1990s. particularly developments around the kind of things that we refer to today of things like complexity theory, chaos theory, all the stuff that went on, the computerization, et cetera. But I want to say that biology, the biologization, let's say, of thought, as it took place in those days, was one of the central events of the 1990s. And what I'm presenting to you today, in a certain sense, is my way of thinking through the questions for today. You'll ask, well, Kwinter didn't mention architecture once. Well, I think that ultimately we really need to go back to some of these old ideas like space when people talked about it, but especially when it becomes a problem of trying to understand the way space changes. And when we need new language and we need new types of, in a way, perception in order to think about space, it's simply the case that architecture does not offer us itself, on the face of it, does not offer us enough, if you like. We really do have to go and seek forms of knowledge, if you like, and other methodologies and other systems of knowledge also to help us find new ways of approaching this thing that we all love, et cetera, et cetera. So let me get into it. I would also say that ultimately what I'm talking about today is the history of the brain, which is essentially an ecological problem and a problem itself of form. I may not always be able to explicitly return us to that idea as I go through this, because I do want to get through it as handily as possible. Most textbooks and surveys fix the origins of the science of ecology in the work of Alexander von Humboldt, particularly his 1802 essay on the geography of plants. Fascinating that this book came out only a few months ago in English in this beautiful edition. There's little need to contest this genealogy, mainly because we do not know what it means in the first place to speak of the origin of a term that has never been concretely defined. What I'd like to present today consists of a proposal not to radicalize ecology. I'm not an ecologist, that really isn't my job, but to ask in what ways ecology may have already and may uniquely be able to continue to radicalize us. The approach to this task will also be an approach toward a needed definition. And that reminds me of the thing that you can't really give the paper I'm about to give without asking you to understand the complexity of talking about this topic, of course, in architecture, just to have it acknowledged. Sustainability is obviously something that everybody either is trying to not talk about or is trying to talk about. And one of the most depressing things, in a way, in the time that I've been associated with architecture in 25 years, is the astonishing failure to find interesting, innovative new ways of doing that. And I want to say that those who do their best to avoid talking about sustainability and the problems, the immediacy of those problems, are failing every bit as miserably as those who are on the other side trying to do it. So what I see is an attempt to try and break through those impasses. As a theorist, my interest in what might be called ecological thinking. The unity and power of ecology as a discipline, I would argue, is not to be reduced to its role at the foundations of biological thought, although it is the foundations of biological thought, but for the philosophical postures and the habits of mind that it has brought into play, not only in the life sciences, but in all aspects of our knowledge systems and our experiential world. Von Humboldt showed how plant shapes, sizes, and behaviors were dependent on variables in the immediate environment, such as altitude, climate, soil, latitude, etc. That's to say the same seed, the same actual plant would take all these different forms based on how it would respond to those variables. One and the same genotype was seen to express itself along a wide spectrum of variations according to which conditions it encounters in temporal and spatial location. How high up on the mountain, for example, would determine the actual form of a given plant. Von Humboldt was among the first to embed the study of forms within a field of influences. This is 1802. And hence began a great series of fundamental changes in how we understand the concept of environment. Environment is really what I'm going to be focusing on today. Ultimately, so you have a sense of what the hell I'm talking about, this is an attempt to basically show that brain and one of the ways that one would do this, to show how brain and what we know about brain, what we learned even in the last 10 years, brain and environment are absolutely inseparable. His phrase, alles ist Wechselwirkung, typically translated as everything is connected, is more critically and accurately, basically it's the wrong translation, should be translated as all is interaction. To von Humboldt, we owe the habits of thinking about form and nature as an expression of interactions that more or less incorporate or synthesize the environment itself. This is both the beginnings of ecological thinking, and these are very important. The interaction idea is one that has been largely missed, if you like, by historians of science, and really extremely critical. Now, every ecologist more or less knows that, but they don't necessarily know it, if you like, at the level, at the philosophical level, at the implications of the philosophical level of what it implies. Just as designers today, who are extraordinarily conversant, for example, in the use of multi-agent interactive software and parametrics, etc., simply have assumed that it is detachable, if you like, from a much broader philosophical implications or underpinnings, and from which the force of any potential deployment of those new capacities, for example, that we get through machines, is entirely dependent. I'll say no more about what value judgments are embedded in that phrase, but we'll go on. But von Humboldt's friend and elder, Johann Goethe, had completed a work on botany himself barely 10 years earlier in 1790 that some today view as the origin of dynamical systems thinking. In this work on the metamorphosis of plants, Goethe supplies a single model of algorithmic explanation at once for the diversity of vegetable forms or vegetal forms, at once for the diversity of vegetal forms in the world, as well as for the diversity of organ forms within the same given plant or the same plant family. Stem, leaves, calyx, and petal, and all forms in between, are related as organizational points in a space made up of three interacting fields of influence: a flexible type, a continuous gradient, and a closed but repeating cycle. So you've got type, gradient, and cycle, and their interactions. It's a brilliant formulation from the end of the 18th century. As Ernst Cassirer brilliantly summarized it, Goethe effectuated the transition from generic thinking, from the habits of thinking about form within the fixed and decidedly typological Linnaean tables of genera and species, to the genetic habit of mind, which sees form as an active process of generation, improvisation, and expression. Here is a second critical component of what will come to be known as ecological thinking: the open, communicative interplay and integration of continuums that possess very different temporalities or rates of unfolding. Every plant and plant part is an expression of one point and moment. That's my P. Every time I say P or B, it's like you're getting hit in the head. Now, I can shout if this doesn't work. Every plant and plant part is an expression of one point and moment in this matrix of interactions. 50 years later, Charles Darwin, in his famous Garden at Down House. It's famous to people who read about Darwin and evolutionists. Notices the powerful tendency of a plot of ground, even a, quote, single square yard of turf. And he literally had a single square yard of turf that he basically cultivated and studied and repertoried, etc., to alter, organize, and transform both the kind and the proportion of elements that make it up. It's incredible when you think about how much science you can do on a tabletop, and how much science, if you like, about the broadest, biggest concepts that can possibly exist, actually, in philosophy or science. Not only does he posit for us the concept of an active composition, he uses the word composition, and hence an underlying, if invisible, set of rules and orders. He identifies these primarily as competition, but sees the territory in question as composed of communities held together socially. And there's the next important idea that needs to be included in the concept of ecological thinking. It's the social aspect of interactions. What this concept of sociality gives us for the first time is an image of an overarching structure or directionality or evolution, as well as the absolutely necessary correlate term, and as the great Ernst Mayr has tirelessly pointed out, a concept that has been almost routinely ignored, even by evolutionary biologists, and that's the idea of the population. For population thinking is one of the great big ideas of Ernst Mayr, who's considered to be the greatest evolutionary biologist of the 20th century. Population thinking I'm not keeping track of my slides. Did I have that thing up for the last 5 minutes or what? Population thinking goes hand in hand with ecological thinking. According to this doctrine, every point and every element represents a potential that is different from every other. Indeed, a population is seen as nothing but a field of differences to be realized or not. What I mean by that is when you see a herd of zebra out on the savannah, you see it as a whole lot of zebra. Family. They're all together. They're all the same. The fact of the matter is, and this is Ernst Mayr who really focuses on it, of course he points out that this is something that Darwin placed foreground, is that it's not true at all. Is the very robustness of that group of entities is entirely dependent on the fact that there is a huge amount of genetic information in there which is divergent. Every single animal is different. Every single animal carries within it, if you like, the potential to evolve along a different path. Stress their environment, certain ones will be selected, et cetera, et cetera. That's the foundation of this aspect of ecological thinking, and that is the concept of population thinking. And it is directly intended to be antagonistic to the concept of type. So it's not the zebra type, it's this population of zebra with their divergences and differences. What is ecological about this is that the differences in the field, the zebra field, stabilize into approximate categories. The species. Sure, you've got the appearance of a species, but the differences do not get extinguished, and the stable forms are at best provisional and illusory. Once again, the true reality of what is going on in a landscape is not reducible to what is seen, but to that in the embedded structure that holds it together, to the organization of forces, and especially to the history and sequence of their appearance in the system. Now, that's a really interesting idea, and that is the degree to which those forms are entirely dependent on a particular sequence that leads up to them, and not simply to the relationships that occur that can be seen in a section in that point in time. The problems introduced by this Darwinian insight have not been widely understood. On one level, they have not been understood by form theorists either. On one level, underlying instability is endemic and universal. Wherever there is information exchange, wherever there is interaction, period, Guys, I'm waking up slowly here. Trying to remember where I am, what I'm doing. On another, the loose confederacies that make up a population represent unities in their own right that interact with other populations even as they interact with the interactions between their own component elements. I'm going to skip a section here. This is the section that has to do with modularity, which is an important aspect also of ecological thinking, but we don't need to deal with it. The point I think which is important now is the fact that we understand that populations interact, with individual elements, but also with the interactions between individual elements. I guess I have to put this down here. Let me skip through something here. To return to this discussion then of Darwin's square yard of turf and the principle of history and sequence, ecological structure continues today to be the object of great mystery. In a series of experiments in the mid-1990s by the ecologists Stuart Pym and James Drake on modeling the artificial assembly of ecological communities, it was determined that in such systems there is exhibited a, now, aren't you glad you missed that one? A Humpty Dumpty effect. In other words, the reassembly of an existing or found ecological community cannot be achieved even if one possesses exhaustive information of the species and relations that comprise it. What happened with these guys, Pym and Drake, is that they had been studying a plot of land and repertorying it, and so they knew almost as much as you could know about a single plot of land, about all the species that were there. And then there was a catastrophic fire, and then they decided to try an experiment, which was essentially to take this incredible data that they had compiled over years and years and years, and just simply bring everything back together and recreate the ecology. And what they learned, of course, which is a lesson for all time, is you can't recreate an ecology because so many of the elements that are in it are actually sewn together by relationships that existed previously in the mix. For example, certain species which appeared for a certain time essentially to mediate between other relationships and interactions in the system, then vanish. But nonetheless, if you like, that work of sort of knitting them together remains as part of the system. So you simply can't recreate an ecology. An ecological snapshot will not render the movements of a living film. The sequence with which the species are introduced, even if many of the species later vanish from the system entirely, continues to structure the integrity of the system long after they've played their visible roles. In some, ecological structure is temporal structure. There are many episodes of importance in the evolution of ecological thinking between Darwin, of course, and Pym and Drake in the 90s, and many that are not widely acknowledged by practicing ecologists. It's worth, by the way, we will get to the brain. I mean, the brain in a way is the great summum, one could say. It's the great invention. It's the most complex object in the world. You've heard that said 1 billion times. It's the great ultimate expression, if you like, of a specific environment, which is what I will eventually get around to talking about. Okay, so what are some of the things? Let me just go quickly through some of these. One case that comes to mind is that of Vladimir Vernadsky. These are things that are not typically fully acknowledged, if you like. A name relatively known today, but almost entirely unknown to English-speaking scientists until the 1990s, when his work from the 1920s was translated into English and came to the attention of people like Lynn Margulis, who was one of the formulators of the Gaia hypothesis. Vernadsky, and I mean, Lynn Margulis, for those of you who know her, I mean, and people like Lovelock, et cetera, they did not know Vernadsky's work. In fact, it was long after the Gaia hypothesis had been formulated that they had discovered Vernadsky. I learned of Vernadsky, for example, others knew of Vernadsky before that, because I discovered him in the work of Georges Bataille, who evokes Vernadsky's concept of an adaptive metabolic spherical system, the Earth, driven by that of another, the sun. There's this incredible image at the beginning of The Accursed Share, the very first pages, in fact, where he describes this amazing image of Vernadsky's. The conversion of energy of the sun into increasingly complex dispositions of matter as the drama unfolds on Earth was seen by Bataille to lie at the foundations of wealth and of what he called general economy. Kind of makes me really wish that Sylvain L'Autringer had been here today. Vernadsky, it was through Sylvain, actually. He was going to come today. It was through him 30 years ago that I discovered Bataille, in fact. Vernadsky was the first, among many firsts, to understand geology and later climate to be driven by chemical and biological activity, and is the inventor of the concept of the biosphere. Strangely enough, he's the guy who coined the term. But it's not just a term, of course. It's a completely radical conception of interconnectedness, of linkedness, and of active interaction and communication. And certainly the idea that our geology is driven by life was a radical idea whose consequences are still being absorbed by science today. A final example is the work of the theoretical biologist Jakob Johan von Uexküll, of whom it can be said that he was, in fact, the father of the modern notion of ecology. We're fast-forwarding in a way now up to the same period, the 1920s. Of preeminent interest is his concept, as you've all heard of one way or another, I think, of the Umwelt. The practical world or environment, it's typically translated as environment, the surrounding world, but practical. It's a practical concept of the surrounding world that corresponds to the sensory and biological endowment of any given organism. In this hilarious, to my mind, set of images from his book, I hope you can read those, if not, on animal worlds, the point is made. The worlds of men, dogs, and flies overlap, but they do not correspond. And what this basically shows you, the things in black and white are the parts of the world which simply do not really figure in the worlds. What do we got here? We've got, that's not part of what we're looking at here. We have, there's the room, according to a dog, who's basically interested in those spots, the colored spots where there's food. And I seem to remember in another version of this is the seats, because they certainly have a certain amount of scent on them. But anyway, there's the human room. I'm not exactly sure why it looks just like the dog's room, actually. But I think a lot of women know why. In any case, we have here, there you go, and the fly is particularly interested. Oh, I see. Frankly, you guys work it out while I talk. The colored areas are the areas that mean something to the animal. But the important idea here is that to every organism there is a corresponding world which includes and excludes other things. It really has to do with its particular aspect, its nervous system, what it's capable. And this is an incredibly important idea because, I'll tell you in a minute, each animal not only inhabits its particular Umwelt, each organism is fully continuous and consubstantial with it. It's that concept of the continuity, the inseparability, if you like, of the organism and its environment, the functional inseparability. The figures in the world that represent assets for the organism, a small fraction of what can be said to be out there, correspond to a sensory system that is both possessed by and which defines that animal. An animal is a segment of a circuit that connects triggers in one part of the environment to responsive actions in another part. In this sense now, we're already beginning to see that the animal or the organism is not something that exists in a habitat or an environment. It is the environment. It is an integral part. It is merely a more complex and layered part of the environment itself. This is what I call the principle of immanentism, a further central feature of ecological thinking, according to which the distinction between organism and environment, inside and outside, is merely one of degree, a greater or lesser compression or dilation of information or life. All right, that's sort of part one. There's still a little more theory coming, but we'll get now into some more specifics. I have been thinking about, and in my way studying, animals for about 14 years, as I recollect it. The interest began in earnest in 1992. It's not like I can't do math. I know that that's more than 14 years ago. But I just want to say this is what triggered it, some kind of shock, if you like. When the National Geographic Organization released the film Eternal Enemies, in which were depicted the most surprising filmed episodes of interspecies interaction, specifically between two distinct families of super predator, lions and hyenas. Can I just ask, for a show of hands, is there anybody here in the room who was here 3 years ago, or whatever that was, when I taught the class on communication? Anyone? All right. I made my students look at this film. I mean, it blows everybody's mind, without a doubt. But I'm still wondering whether they fully understood what its impact could be on thinking about space. At the time of the film's release, 1992, I was living here in Los Angeles at the time. I happened to be reading Bruce Chatwin's remarkable study of nomadism called The Songlines. The film study by Beverly and Derek Joubert, by the way, some of you may know this, they've come out with, there's a film now in the movie theaters. This is a theatrical release of a nature film, this film on lions. Has anyone seen their new film on lions? Like I say, this is Los Angeles. Nobody goes to the movies. All right. That's surprising. We're crazy about it in New York. Jesus, we all study animals. It's a rare thing. I mean, it's not as great. There's no way. I haven't seen it yet myself. The new one on lions can't possibly beat the one that I'm talking to you about now, but it certainly did earn a theatrical release and has been able to sustain its presence in the theaters for now many weeks. Formed for me a decisive philosophical pair. They struck me as the most significant insights I had come across in years regarding the nature of space and human being. Chatwin's book included interviews with the founder of modern anthropology, Konrad Lorenz, meetings with African paleoanthropologists, and speculations on the predatory pressures that shaped the evolution of human consciousness and life forms. In both works, both the film and this book, cats, hyenids, were pitted together as the foundational forces and fields in which the human type emerged. And that's basically the most important. It's the most important insight that's reflected in these works. This has been. It's got its foundation in the speculations of some of the greatest anthropologists and animal ethologists of the 1960s, particularly Sherwood Washburn and George Schaller and others. But it's an amazingly important idea to see the development of the human form and the human type as far more directly linked to the evolution of these super predators and social carnivores with whom they shared essentially ecological niches, and not at all the concentration that cliche applies to them, which is essentially the evolution of apes, if you like, to more intelligent, tool-wielding, language-using, etc. Apes. Some years later, I'm talking about myself now. Some years later, still in full thrall of these two documentary essays, I had occasion to travel to Africa with the express purpose to visit the specific sites in which they did their respective field work. I'm hoping that Jeff Kipnis is smiling now, because I remember when he went off to his trip in Africa, I think rather reluctantly, he came back with his mind blown, I remember, and certainly saw some of the things I'm about to describe to you. To see for myself if what these guys were talking about were in fact, could they even possibly be true? Within hours of my arrival in the bush, after an unbroken 23 hours flight from New York. I awoke from a nap I was taking in a tree. I didn't just end up in the tree, of course. I was placed there by guides upon arrival in... Now, it's important to say because, you know, the guys took me there. They put me in the tree, gave me a pillow and a canteen, said, do not get out of this tree no matter what happens. I'm thinking, what could happen? It's a beautiful day. Here we are in the bush in Africa. It looked like, you know, it looked like a large field in Central Park. Then they left me. And I experienced the most astounding 2 hours of my life. Well, I fell asleep, and then I woke up. And then the 2 hours, like I do every time, like before a lecture, I fall asleep. And sometimes in the middle of the lecture, like you're going to do perhaps. The quiet, almost benign-seeming thorn scrub landscape, with its emptiness and almost infinite vistas, had come to life as I slept, and I was awakened as if by the bustle of a market in a Mediterranean city, by the sounds of a primordial commerce that I knew I had never heard before, but still somehow knew. There was that uncanny feeling of feeling somehow weirdly at home in it. The waterhole next to which my tree was perched had become the site of what seemed a spontaneous generation of life. Wave upon wave of organized animal herds descended in rhythmic turns to the cool pleasures of bath and drink. First the elephants, then the warthogs, the giraffes, the springbok, then elephants again, then larger antelopes and baboons, hornbills and egrets, and then a few tentative mixtures of groups. It's interesting how after a while, after the first movements, then they start to mix, they start to appear together in certain groups in decidedly non-random order and pairings. That's to say that the potential for these pairings at the waterhole all depend on a kind of distribution of stress and tension in the environment, which you can feel. The incredible insouciance and playfulness of the elephants, they're the kings, they have nothing to fear, was strictly contrasted with the nervousness of the ungulates, the almost painful contortions of the giraffes, who must spread their legs so far apart to allow for their mouths to reach the water's surface as to place them in grave susceptibility to attack. It takes a while to get those legs back together and to start running. They also can't kick when they're in that position. They must also close the valves in the arteries of their necks so that the immense blood pressure levels needed to carry blood up their necks do not cause their bowed heads to explode. These were my first hours in the African bush, and I still knew nothing about how to read a landscape. But the presence, and this is the point, of multiple pressures and dilations in the environment of behaviors was palpable to anyone with a nervous system. My eyes scanned the scene in something close to shock. Certainly the procession of forms and fauna was astounding. But what amazed me most was the broad pattern, the deep, almost familiar rhythms of appearance, the immediate way in which my brain began to react by adopting a kind of magical consciousness, taking on the sudden irrepressible belief, actually a kind of weird projective belief that the animal patterns were actually being created before me and were not simply being revealed. And when I say magic, I mean, it's important to understand, well, I mean, I don't know how much I'm going to be able to get into this, but this is one of the extraordinary aspects of the extraordinary postures that was available to humans in the hunting mode that had evolved and which allowed one to fully read an environment. And what I want to argue about this is that form reading is something for which we were very highly selected for. It is one of the central aspects, if you like, of our evolutionary endowment. It has everything to do with these kinds of environments and all of those pressures that exist inside of it. But it also means that there are certain ways in which we have essentially turned our back on many of them. And that's something I'm going to discuss. But basically, I'm also not going to stay in the hocus-pocus world. I'm going to talk much more concretely about anatomy and biology. Some hours later, the guides returned to retrieve me with a thermos of gin in tow, which was at that time an extremely welcome libation, for at this time I was, frankly and finally, paralyzed with fright from harassment by a merely curious but seemingly unhinged adolescent male elephant. The adolescents of all large-brained species are a problem. And it's a fascinating thing you see all around Africa is they are creating problems, and then you all see the big elephants coming and saying, you know, toe the line. Anyway, the point is that that's what the males do. They come, the whole group of elephants moves off. The guy comes back and he starts like scaring the shit out of me. Threatening, but I don't know anything, right? This is my first hour, okay, in the tree. I haven't studied any of this stuff that I'm talking to you about now yet. And frankly, you know, that was one of the scariest moments of my life. The guides mounted the tree, this is when they come back, and began to identify the landscape's slower and subtler unfoldings and bass notes. Against the tawny Kalahari dust, and at a distance of no more than 400 yards, they pointed to a dappled patch of stirring, ever so slightly grayer surfaces, you know, in the field, that were, to the knowing eye, not mine, the unmistakable collective pulsations of a pride of hunting lions. The presence and proximity of these predators, I immediately knew, had been the metronome, or better perhaps you could say the conductor's baton. It had both and I want to point out the musical trope here is not, it is deliberate, that had both regulated and charged the scene for the last hours. Every emotion and startle that had passed through me in witness to the flow of Pleistocene life passing before me that amazing afternoon had been a product of sensations transmitted to me within a web of communicative actions and interactions of which, to my infinite surprise, I myself had played an integral part, just as did the pride of lions, despite the fact that I had never been directly aware of it. Now, what I want to say here, of course, is the communicative web. I mean, you suddenly discovering yourself not observing it, but actually playing a role in it. That's to say, continuous with it is a shocking thing. But it transforms, if you like, the entire perceptual event. Those of you who, what would the word be? Let's say, who speak ill of phenomenology, may wish to rethink and pull out of the trash bin some of these aspects and ask oneself how these things have been rethought of, because there's simply no doubt about it. The corporal, the somatic aspect of, I mean, it's really, we really must understand that the eyes are not the sole organ through which these processes are taking place. This, in sum, represented the dawning of a cascade of intuitions that overtook me in the weeks and then years that followed that remarkable afternoon. I have never been able to see space or landscape in quite the same way, yet I've not even begun to describe the insight that I believe I stumbled upon that afternoon. For in the 3 weeks that followed, and on several subsequent trips since then, I spent each day during the hours around dawn and dusk in active submersion in the environment, actually cognitively hunting, as it were, searching for animals, or, as I came to call them, animal events. One quickly learns to search not so much for objects and things, this is part of the training that begins to take place, as for patterns, actions, disturbances, for a larger modulus that one could call, of that which one could call behaviors. One searches for so many emergences of concentrated intelligibility against the more dilute, or shall we say, the more slowly unfolding and differentiating backdrop of geology and plants, In some, it's a search for differentials. Now, what's important to understand here is that these systems are sliding and moving continually against one another. Those who see these things as mobile, transitional, and moving, that's essentially what the hunter-gatherer, that's what the hunter-gatherer's world is like. Their capacity, I'll tell some stories perhaps later when we get to some of the ways in which this stuff has been empirically tested. But that's what the posture, that's what the particular use of the nervous system in this case does. The animal, to he or she who adopts the position of hunter, and we are all hunters when we dispose ourselves to discern pattern, meaning, and opportunity within the space we inhabit, is a literal byproduct of the environment, an expression of the environment, a literal synecdoche, which is a rhetorical a rhetorical term in which a part serves to represent or express the whole. Yeah, that slide should explain synecdoche. It's within the strange and, in today's world, idiosyncratic posture of hunting that we discover that we too are part of the whole. Here, and I mean literally, I'm not talking about a New Age kind of thing here, that we come to understand that our animal is continuous with those that we seek and find, the ones we humans primevally had been required in the name of survival to seek and to find. The hunter seeks the animal, seeks to subdue and incorporate it, and in the hunting, the animal is often said to migrate into the hunter itself. Hence the universal lore in hunter-gatherer societies regarding presentiment, or what is sometimes called somatic precognition. This is an old cover of a great work by Elias Canetti. The idea of presentiment, which I'll explain in a second, the idea of presentiment, the phenomenon through which the hunter is said to feel the markings of the animal he seeks, first as a tingling in the armpits, then as a tattoo of sensation drawn on his own skin, was famously documented by Nobel anthropologist Elias Canetti in his remarkable and influential work, Crowds and Power. Khoi and San Bushmen, these are the famous Bushmen of the Kalahari, but also other hunter-gatherers, are renowned for their astonishing ability to track animals and to accurately deduce their actions, their gender, age, level of fitness, maternal status, even intentions and mood, entirely from disturbances or marks on plants or in sand or rock. Indeed, this systematic use of the senses to mine the environment has credibly been argued to represent the first appearance of a scientific attitude in human culture. This is the book where that idea was explicitly first proposed. It's an impossible to get book, though I've been in touch with the author, and he is now rewriting it. He is... Not that you're going to know him. I mean, he's a guy who spends his whole life in the bush, but he did win a Rolex Prize, I think in the mid-1990s, for having developed these tiny computers that I once wrote about in Wired magazine, these things that I think I referred to them as Stone Age computers. They were these tiny handheld devices that he would give to the Bushmen, and they would enter the data that they saw, and this stuff would be automatically uploaded and downloaded to the university in Witwatersrand. But what it did is it created a database, a kind of a live sounding or repertorying of the environment. It gave such an enormous amount of data to researchers to know exactly what was happening and the exact ways in which the animals were using the environment. Consider the following, the opening passage. I should say something else. It was in 1991, P.T. Stander from the University of Cambridge, who is an active researcher especially on the predators of the Kalahari. He, as everyone does, these Bushmen are indispensable if they're looking for animals and if they want knowledge about animal behavior. he decided to put their abilities to read the environment to a test. And in some, I mean, the article is available online. In some, what they did is they videotaped events that took place in the environment, usually a kill or something like that, and they waited up to 48 hours for the environment actually to alter and in some ways to obliterate the signs. They would bring these bushmen in, and then they would ask them to describe exactly what happened. And that's usually several events. The attack took place here, the leg was injured here, they went here, they would tell the whole story. They found they had 98.5% accuracy. So their capacity to read the environment is probably better than our own ability to read a painting that's in front of our eyes as we speak about it. Consider the following, the opening passage from a treatise on tracking. And really I want to say here in a kind of a shorthand is the capacity to track is probably not only the origins of the scientific posture of this, that's to say the origin of the way of using the brain, if you like, using the nervous system essentially to organize and retrieve this information of form, to read deeply, if you like, into global form. It is, and this guy argues, is the origins of science. And I forgot what I was about to say the second thing was, but we'll get to it. This is by an American wilderness guide. I love this thing. It's the opening of a guy in New Jersey who's the greatest tracker in the world, the greatest non-hunter-gatherer tracker in the world. I don't think there are any hunter-gatherers in New Jersey. You never know. The first track is the end of a string. At the other end, a being is moving. What you have to understand here is the sense of being connected to the biology, not only at the end of the string, but also the string itself, if you like. And that is the posture, if you like, that makes the tracking capacity possible. A mystery, dropping a hint about itself every so many feet, telling you more about itself until you can almost see it, even before you come to it. Now, what I'm saying here is a guy in New Jersey has also that profound intuition of actually creating a physical, somatic image, incorporated image of the hunted animal, or to say that form moving, if you like, at the end of its own nervous system processes. One could say that a fundamental scientific insight, forget about this. This goes back to Michelet. Nobody really cares about that. The bottom line on this simply is that he was the one who posited in the 19th century the idea that a bird could not be thought of independently from its nest, that the organism was the total thing. Now, this is an idea that turned out to be fundamentally true of biology, in fact, of where biology went. What do I have here? I should probably, what every animal teaches us, and I use the word animal here to refer to the capacity of any living process to mark or transform its environment, is that the animal is what makes space something rather than nothing. It's what determines the positivity of space, even in the absence of concrete forms. What determines its capacity to organize, to affect, and to move. Now, part of the reason a theorist can get up and say these kinds of things and not be booed and thrown out is simply because we all know that the non-concrete aspects of space are things which have become intensely immediate and necessary for us to engage, to get our hands around in many ways in terms of design, and certainly in terms of design thinking. The animal is this in two ways. First, because it represents a condensation or a contraction of the relationships in landscapes, climate, geology, vegetation, history, relational webs with other animal forms, etc. And secondly, because endowed as it is with capacity to move and energy to expend, it represents a volatilization of space, an instigator around which space and being happen and unfold. This is precisely what the philosophical anthropologist Georges Bataille sought to express when at the beginning, again, of that book, The Accursed Share, he declares, The sex act is to time what the tiger is to space. Both are forms of prodigal combustion. This is what you're going to remember from today's lecture, this particular slide, and probably very little else. Now, when I say combustion, I mean precisely that, and in two ways. When one burns or combusts a log, let's say of wood, one harvests the potential chemical energy invested in it by the life of the tree that gave it form. In many ways, this economic relationship is the same one Bataille spoke of when, following the work of Vladimir Vernadsky, he described, there's the book, yes. He described the Earth's system and human civilization as a direct extension of Earth's geochemistry, as one of managing and administrating the sun's energy. This was the great insight of Bataille in terms of what he called his political economy, or his general economy, both trapping the sun's energy in stores through photosynthesis, et cetera, and all the chains of, all the food chains, as well as expending it and letting it go free. I just want to point out, this is the book we published, of course, at Zone Books. The cover, you can't see it. We designed our covers so that they were essentially intelligible as forms only when entirely opened up and unfolded, the gatefold and everything. But what you're seeing there, of course, is an image of the sun and the sun storms, if you like. The landscape in its entirety is a dynamic material world and is a product of invisible algorithmic forces and logics that shape and direct it in accordance with and in accommodation of all other forces and logics present within it. It's an astounding thing, the way essentially the organism and the environment combust one another, or let's say project themselves into one another, or contract into one another, or dilate one another. When we study these relationships with reference to the forms that they produce, we call it evolutionary theory. But we also, and increasingly, call it ecology. This connection, I would argue, is extremely profound, still incompletely acknowledged, and paramount. It is one that is necessary to adopt today. Having said that, and a kind of a short form thing I would like to say is that so one of the things not only is this kind of technical sort of philosophical stuff so critical, we need to be thinking of bigger ways about how we think about our relationship to the environment now. But I would like to say this very simply. This is obviously a great place to say this kind of thing. The imaginative emphasis on imagination, the imaginative elaboration of these concepts is really important. I didn't always believe that. I really believe it now. I'll tell you why at dinner. And yet, animals do not study evolutionary theory, nor do the human cultures whose livelihoods depend on hunting and harvesting them. Rather, what animals and hunters do is enter into communicative webs with one another, since they must either ingest or evade one another in order to survive. They must attune their nervous systems to one another's actions, and particularly to one another's actions on the environment. Now, this is a very simple formulation of something that's really fascinating and really complex and interesting. A simple example of this is just the way in which, for example, the hunter-gatherer is constantly aware of the way they disturb the environment and the way in which they, through chains of interaction, will actually alert the hunted animal. There is a lore, now since proven to be more or less true. The lore that went on obviously for 25,000 years among Bushmen was that during the hunt is to essentially not let insects settle on their body for fear that the flies will carry the scent of their sweat to the hunted animal. We now know this to be essentially true. It reminds me as well of the story of the Andaman tribes in the mountains of a particular island off the coast of India during the time when the great tsunami of 4 or 5 years ago occurred, when they were announcing that all of the Andaman islanders had been wiped out. This ancient civilization, many of whose members actually had never had contact with the technological civilization or the West, etc. These are people who had never seen, ever seen civilization as we know it, and they were just assumed to have been entirely wiped out. What they found out some weeks later is that they all survived. The question then came is like, wow, how did that happen? It's not like some mystical thing happened, ooh, they could feel, they could predict the future, etc. No, it's very simply the case that the Andaman hunter-gatherer tribes were simply highly attuned, if you like, to these differentials, these changes that occurred in the environment. Clearly the fish, the behavior of fish, are the first animal fields, if you like, to begin to respond to the changes in the aquatic environment when the tsunami and that energy, when that kind of front begins to change. The birds who hunt them, the predator birds, then, of course, themselves took that as a certain kind of sign. Their behaviors were changed, and on down the line to the the various animals that existed on land, etc. And clearly, the Andaman peoples noticed it. They all went to high ground, and they survived. The ancient biological tuning. This ancient biological tuning, too, is a form of tracking, a form of knowledge practice, a form of combusting the legible organization in the environment. When two animals are locked into evolutionary struggle with one another, say through competition for the same food resources, or as part of a predator-prey relationship, we say that an arms race is occurring. For example, and here's the story now. I give you a kind of a story of the brain, the evolution of it. Millions of years ago, when the Earth warmed and many climate systems dried up, grasslands replaced much of the forest cover. This gave rise to the first mega herbivores. These are immense, fleshy animals. Huge animals like today's elephants, but even larger, that graze and concentrate huge portions of the landscape's flora and plant bounty into its body in the form of meat. You got these big traveling stores of meat. I think we talked about meat architecture just in the minutes before this lecture. I think maybe you guys want to take note and start drawing this. What is this thing? Ground sloth. They have a weird they have a very weird skeletal structure as well that makes them somewhat. It's a kind of what they call an anti-predator adaptation that resists long-toothed animals. I don't know how. Well, anyway, there's the belly, of course, which is the vulnerable spot. As the rule goes, where there's prey, or rather, where there is prey, there are predators. Where there is energy, there will be combustors. Thus, saber-toothed cats evolved, specialists of a specific type of thrashing kill, to which the mega herbivores were vulnerable and the cats thrived. A long lecture we have tonight. We're just getting warmed up. I should really not add these little things, but what's fascinating to me is that the saber-tooth form emerged 4 completely separate and distinct times in history, which is to say that there is a kind of virtuality of this particular machine, if you like, this particular kind of killing machine. That's to say the environment itself calls it forth whenever the conditions are right. It's a fascinating thing because there is no real connection between the species that evolve it. Soon, new species of hyena, that's a problem, boy, when the hyenas arrived on the evolutionary scene with totally different behaviors to scavenge the remains of these kills. When humans arrived sometime later, the mega herbivores were a prime and viable prey, and the famous cerebral and social efficiency of the humans ultimately denied the saber-toothed cats the only meal they were adapted to procure, and they soon died out. What you've got happening here, of course, is the arrival of the generalist, the unbelievable power of the generalist, simply because they can adapt very easily to the transfer. When the environment starts changing quickly, the generalist does not have to find an evolutionary solution. It can rely on its own plasticity, behavioral plasticity. The hyenas, generalists that they were more versatile, and so began to evolve in a new direction toward accommodation of the new species imposing on their habitat, the humans. And here's where the hyena-human co-evolution, or what they call in anthropology convergence, begins to take place. Here the webs of influence and communication, although largely imperceptible, but are actually embedded. They take place over great periods of time and are not available to perception or to discernment within the attention or even the lifespan of a single animal. Yet the efficient transfer and circulation of information takes place regardless. The world and the species that make it transform. This is one way in which the landscape is continually harvested or combusted by animal continuums. But it is not food and the energy stored within it that is in play here, but rather the economic information produced within and distributed throughout the broader ecology. That's the next really important, well, I mean, from what I have to offer, that limited amount I have to offer, that's an important aspect that is largely unaccounted for in contemporary ecological thinking. There are many forms of environmental combustion. I would like to give two examples. I want to get to the brain, of course, but teeth are incredibly important, possibly even more important than brains. I don't really have time for both, so let me just pass over some of these things. I should say some things about about teeth. Nonetheless, what do we got here? Give me a minute. Teeth in some, I would say, are the principal determinant of what part of the landscape and in what modality the animal will seek to combust. The teeth are the cornerstone, you say, in architecture. They are, what do you call it? Not the cornerstone, the keystone. They are the keystone. The teeth are the keystone in our relationship to the environment. That's it. It's a great idea, keystone. Teeth tell the whole evolutionary story, and nowhere more dramatically than in the ecological transition stories of ape to man. Those of you who don't pass over those stories on the front page of the Los Angeles Times when they discovered some new, very partial hominid findings in some part of Africa, and they're basically saying, well, we found a tooth, and whoa, you wouldn't believe what it means, and they'd start telling you all kinds of crazy stories about how the animal, or how the human or hominin lived, and what it did, and how they made love, and what they did, who they did it with, et cetera, all based on the tooth, essentially, because you can tell virtually everything. They tell the broader story of the evolution of vertebrate predation and the general distribution and parceling of resources in the environment. Because they look at it. That's how the evolutionists, the evolutionary biologists think about things. It's essentially economics. It's where the tooth, it's how the tooth fits into the economic life. There's no flower, for example, that has not incorporated these often sanguine and violent stories and scenes. It's all about how you kill and ingest another animal. Let it be said, then, that the story of teeth, which is probably the most detailed lesson in adaptive form that we have, which is why it's interesting to study, simply because it tells you how, it gives you ever see, you guys don't remember this because there are no more formalists, I think, in architecture. But there was a time when we used to go to juries and there would be the guy, the formalist, usually wearing a tie and sitting there with a kind of a sour look on his face. And a thing would come up, and at some point they'd stand up and they'd start doing this incredible routine, like James Cagney dancing across the floor in one of those films. and they would start to do an analysis, and they would take a single little line and a single little curve, and essentially they'd unfold this whole thing. And that essentially is what they do. They learn to do with teeth. But the important thing I want to bring up here is the whole idea of the carnassial tooth. It's the at some point in history you get not the saber tooth, which means not. It can be used in one way. It's very rigid in terms of what kind of flesh, what kind of animal it can actually subdue. The carnassial tooth is interesting because it does two things. First of all, it shears at incredible efficiency. You can lop off huge chunks of meat and just pop them down your gullet in no time. They're also capable of supporting astounding amounts of pressure and crushing. So you could do crushing. So all of the things in the environment that can only be ingested or whose calories and nutrients can be absorbed only through a crushing action as well as through a slicing action. So what we have here is something really important. The carnassial tooth arrives on the scene. There's some great videos on this, by the way. That's how you learn about this shit. You watch videos. I mean, it's the poor man's trip to Africa in a certain kind of way, but in certain ways what you find out is the biologists. I have time at Harvard, for example, I have access to these guys. And I say, I finally got the courage up to say to them, I say, you know what? I know a guy with a high school education who knows more than you about animals. And they say, you're damn right. Those guides in Africa, because they live there, they're all there all the time. It's what they can take in through, in a certain sense, through observation and the thousands of hours that they have. Okay, the carnassial tooth gives rise to the omnivore, the omnivorous combustor, the generalist, whose lifestyle importance, whose lifestyle versatility created the ecological opening to allow evolution, that force, that mystical force, let's say. I don't mean it to be mystical, but let's just think of it as a mystical force, a form. It's an architect. Evolution is the architect, let's say. To allow evolution to bear no further on major body plan issues, but at last gets to focus on something else, which is brain development. So the fact of the matter is the animals that developed the carnassial tooth, that developed this engine, this versatility engine in terms of their body and their capacity to combust the environment, now have the potential, because they don't have to have an evolutionary adaptation. Brain becomes the focus on brain development and especially neocortical plasticity. Enter the large brain. Large brains are clearly enjoyed by most of the animals that own them, but the fact remains they are extremely expensive. This is one of the great things in recent biology, the expensive tissue hypothesis. Everyone's talking about it. So far as I know. For not only are brains extremely expensive to run, requiring a great deal of high-quality food to power them, their high metabolic rate makes them prodigious producers of heat, and so they are also very expensive to keep cool. But as the newest stories about co-evolution of landscapes and organisms develops today, we are also learning that climate change, not today's climate change, but who knows what will happen, specifically the dramatic heating up of the environment 4 to 5 million years ago. There was this incredible peak. That was one of many peaks, but the peak that was really significant for everything in our world is the peak that happened 4 to 5 million years ago, was a prime cause, or maybe a precondition, of encephalization and hominization. As the environment got hotter, it also got drier, at least in Africa where it mattered most, in the late Pliocene and early Pleistocene, causing forest habitats to shrink and savannas and grassy plains to flourish. Apes, as the story goes, needed to find food out in the open, a dangerous place fraught with seasoned predators, and so required an advantage of some type to protect them. So these are the apes now who really need an adaptation, and they need it soon. What they got was several, as you can guess, interconnected ones. The first set of problems requiring solution was how to move quickly through the dangerous open spaces while carrying one's young. This problem was said to be solved by upright posture. And the freeing of the hands for novel uses. With a new set of ecological potentials for the hands, freed now from the brachiation that is characteristic of virtually all apes and many, many monkeys. Virtually, there is no real animal besides humans that don't brachiate. That don't brachiate. Came new cultural possibilities. The central problem of hominoid and hominin ecology essentially is this cultural aspect. Freed hands provided an opening, or perhaps even a demand, for a new and enlarged brain to program them. And this resulted in the rise of the tool industry, the use of the fashioning, the rather sophisticated fashioning of tools that happened quite long ago, which was even mastered by Neanderthal and Homo sapiens species. But the new environmental heat, that's the real key, actually, at least according to the most recent stories. The heat placed an unprecedented stress on the animal to keep cool. This was now seen to be the driving element. A large, sensitive, heat-producing, and expensive brain represented a dangerous added burden for this animal that has now no longer got fruits and tree cover and climbing capacities to protect it, unless a highly innovative system of cooling could be found. Among the arguments that I find interesting today have argued that the invention of a novel air conditioning system constitutes the defining feature and even the evolutionary impetus behind the emergence of the human species. Because humans have large brains and short faces and special teeth, all effects of the environment-derived pressures to change diet and hence modalities of combustion. Our teeth are absolutely suited for what they call a high-quality diet. They do not possess snouts. We just don't have snouts. And therefore, we lack the hollow nasal chambers and the venous adaptations in the head that most animals use to cool the blood that feeds the brain. Snouts simply serve as radiators. If apes aspired to compete in savanna habitats, they were going to require innovative adaptations to manage the heat stress that came with the environment. All other savanna animals, with the exception of humans, use what is known as selective cooling based on the protruding face, the hollow snout, and a particular adaptation called the carotid rete, which is a kind of a bulge in a certain venous structure inside the head, sometimes in the snout, sometimes in the sinus areas of the neck for cooling. Humans simply cannot do this. Their brain is proportionately too large and would require a neck as wide as its thorax. Some humans have a neck like that, it's true, but we don't have a football team here at school, do we? No, we don't see those kind of necks walking around. The humans need what they call general or full body cooling. And this is one of the most important adaptations of humans. It also explains, of course, as you'll see, our nakedness, which, there are some incredible theories out there about that. The most amazing of which, because it's still tolerated as science, is I'm going to just tell you this for those of you who want to look this up, the aquatic ape hypothesis. Fucking fascinating when there are, including one of the greatest anthropologists of all time, Tobias in South Africa, claims that the aquatic ape hypothesis has some merit. But the point about it is these aren't first freaks. These are actual scientists who have compiled all the possible data that we actually spent a portion of our evolutionary history in the water. It is nonsense, but however, we do know that, I shouldn't say that. What do I know, right? Like at SCI-Arc especially, when we see what architecture looks like, who's to say that we weren't aquatic apes? However, I recently learned, some years ago I read about this group of, I believe they're Some islands in Indonesia has a civilization of humans who live essentially on and in the water. It's incredible. They spend up to 90% of their lives on boats or in the water, and they hunt in the water. Now, what's fascinating is they have adapted. No, that's not right. They haven't adapted. Well, there's some capacities that they have, for example, that no other humans have, which is one thing is they can actually control the size of their pupils, so they can see really clearly underwater. But they can focus underwater better than any other group of humans. They've simply mastered a kind of technique most of us don't have control over, but we would if we had grown up with them. But they can hunt 75 feet below the surface of the water. You know, there's a lot of ways to be human. The first adaptation towards this end is said to be the achievement of upright posture, which has been calculated to cut heat load. Here's where you get into the kind of sustainability measurement kind of thing. But these scientists have measured it. Standing upright exposes far less of the animal's body surface to the direct rays of the sun. You get a 30% savings in efficiency. It also moves the brain and organs away from the ground surface where temperatures are significantly higher. Something that I learned, is incredibly fascinating is the steepness of the gradient of how the environment gets cooler. But, 2 inches away, 6 inches away, 15 inches away from the ground. The heat is really bad down low. And raising your genitals and other parts of your body and your brain, etc., up even a couple of feet makes an enormous difference in reducing the heat load. The second is the shedding of the fur covering, the development of naked skin, and the profuse sweating that permits ultra-efficient radiation of heat through evaporation. But for this last, the bottom line here, you guys, is simply that we have to cool our whole bodies to keep our brain cool. Keeping our brain cool is incredibly serious. We're essentially machines. We're essentially a brain with a machine to cool the brain. But of course, we have this capacity. The other thing I would like to say to you guys, a book came out just a couple of months ago based on work that's been published over the last 10 or 15 years, which has taught us some astounding things, most importantly of which is the human can outrun any animal on Earth. And it now seems pretty clear that what is known as persistence hunting, that's to say running down prey, running down animals, even powerful animals such as like kudu, and is entirely within the capacities of the human organism to be able to do. And it simply is hypothesized that this was the fundamental adaptation, if you like, that was, let's say, delivered to us by the upright posture, or which drove the upright posture. It allowed us to get those animals no other way, because our fingers can't even break open a carcass, even if a carcass were there. You need to get it. You need to let the hyenas or the lions come first, and then you got to learn how to shoo them off of the carcass if you want to actually get those calories inside of it. But the fact of the matter is we had tools, etc., thanks to the old brain, but it's not thinkable, if you like, the kind of whole world, if you like, the human world, unthinkable without that fact. That our capacities for running are, and that we are the running animal. We can outrun a horse. We can outrun, there's no animal on earth. You can outrun any animal. I wouldn't risk it in terms of, running from an angry elephant. You don't get out of the tree. But it's true, in the short term, you're going to get massacred. In the long range. Now, there's a film I must tell you all about called The Great Dance. I believe it may even be in your library here, because when I taught here, I showed it to the students. It's a fascinating thing. They actually filmed in 1992. They filmed a persistence hunt by the last guys who could do it. 140-degree heat. These guys run for 7 hours until the animal, I won't even tell you the story. I think I got a point later on where I can tell you what happens. According to the lore, 150 years of anthropological sort of note-taking, etc., the animal gives itself to the hunter at the end of this noble, endless, painful hunt. And what you see in the film, astoundingly, is you'll see exactly that. We now know the biology of it. The simple fact is that humans, without realizing it, boil the animal's brain. By running and harassing as such, harassing the animal, the animal's brain overheats, at which point at the end it becomes completely delirious. It's just on the verge of death, and it does. It walks up to the hunter like a tamed beast. And the hunters, of course, interpret this in some way as a rendering. We're at sweating. Is that where we're at? We're at sweating. But for this last adaptation, the animal would require regular access. I'm trying to give you a picture, painful, you don't have to, I'm trying to give you a sense of the way behavior, I'm really trying to incorporate behavior into the form problem. And it's through a redrafting of the whole context, through the ecology and the ecological thinking that makes this both necessary and possible, and that makes it reasonable. The humans need to have regular access to considerable quantities of water on a highly regular basis. That's to say, virtually an absolute minimum of once a day, and preferably at least 2. The increase in travel range and the size of hunting and scavenging habitat was an important result of the entirely novel form of human bipedal 2-foot locomotion and the cerebral cortex used in calculating interrelationships, navigational and otherwise, even in keeping a store of where everything is. Now, I know this from the times that I've spent, with far more knowledgeable people than I in Africa, but elephants, they have incredible capacities, of course, for scenting and sampling the environment. They remember where the water is. They know it. They have years of memory. That's how they survive, basically, is by collecting. And then they're, one of the great large-brained mammals with, relatively large cortexes. So what we see here, of course, is these things are inseparable from one another. I've read, for example, that baboons and other apes, chimpanzees particularly, simply never leave their home range. Even if you chase them, they will go right to the edge of their home range, and then they will turn around and start running back. Despite the fact that their stereoscopic vision, like ours, allows them to see great distances. It would seem that humans are the only primates who can and do go where they see. Humans are, in a way, the most adventurous proto-ape species. Whether it's the brain capacity that delimits the psychogeography of the baboon or the chimpanzee is simply unknown, or only research, let's say, and speculation can begin to answer that. But water resource management is clearly a very different affair in highly encephalized mammals. It's cognitive, as I said, in the case, as we know, of elephants and humans, and not only perceptual, meaning it doesn't rely on a capacity to sense it. What we encounter here, and at every level and turn, is a whole modulus, or network of relationships and especially forms, each changing in collaboration and communication with the others. But there were other more internal and less visible transformations that matter, ones involving feedback relationships. Among the most important is how the emerging human form and the human cultural type managed not only its heat budget, but its metabolic budget as well. If the brain is made up of expensive tissue that requires a great deal of extra calories and water to maintain, it is also true that no animal could maintain such a high-maintenance economic life if it did not have a very large brain. But more basic than this is the way the body itself sought to balance the books. It's been widely noted that the human gut is very short compared with that of other mammals for its relative size. Indeed, it's exactly, or almost exactly, half of its predicted length. In addition, physiological studies show that the intestines contribute as much or more to an animal's basal metabolic rate, which is the rate at which an animal burns energy when it's completely at rest, than does the brain. Intestines, it turns out, are also very expensive tissue. That was not always known. The massive increase in human brain size, according to a widely discussed theory, was thus balanced by a decrease in gut size, and this had definitive repercussions on every aspect of the human world. Shortening of the gut, changes our food and feeding culture. Feeding culture, in some, begins to change our domestic culture, our relationship to the landscape and to others. Our mental life as well gets transformed in the process. The first and most basic effect was to require a whole new approach to eating, and I would cite for you this great recent book of Richard Wrangham called Catching Fire, in which he goes through the whole gamut of things that he talks about, how disastrous it is to imagine that a species like humans could live off of raw food. He shows it's simply impossible evolutionarily that they could even survive a single generation eating raw food. The absolute requirement for very high quality, nutritious foods that can be eaten in small quantities but at frequent and regular intervals. Total change in the feeding habit, of course. This meant highly selective foraging and judicious. Some people accuse me of not spending enough time talking about the gatherers. And I mean, I really have to say, it's the same thing. It's still a hunting process. Selective foraging and judicious identification, particularly of the reproductive organs in the environment. Those are the most nutritionally dense foods, such as seeds, tubers, nuts, eggs. It also meant procuring protein and fat in the form of meat, an activity requiring immense adaptations for strategic hunting, which incorporates, of course, the problem of social life. Social hunting is extremely important, and that certainly does take a certain kind of brain. An activity requiring immense adaptations, which included the need to act in coordinated and cooperative social groups, and even, as researchers have recently begun to speculate, to the rise of the family group, and then this whole issue around the division of labor and the age-old relations between the sexes, et cetera, et cetera. They do speculate on these things, you know, because it turns out there is not a single, I hope, I'm not saying this for any kind of, what's the word, political or polemical thing, but it turns out it's fascinating. There is not a single culture known, past or present, well, I shouldn't say that, in a past where the men cook. Isn't that wild? The women always cooked, the hunter-gatherers. Nobody wants to, like, scream or yell at that. It's like, Jesus. Well, you know, fascinating now, the guys have this whole different approach to cooking, with, the molecular gastronomy, and they want to bring machines into the kitchen. Whatever happened to the magic of just using a little bit of magic? But the bottom line here, and I realize that I must now rapidly conclude, is to affirm that the large brain is at once directly and indirectly a product and an expression of climate and ecology. It emerged as a response to an increasingly hot and dry environment, and in tandem with the evolution of a novel and biologically unique cooling system. But once the movement toward encephalization began, a broad set of other regimes necessarily were triggered based on the need to extract from the environment the resources to keep the brain running. It's hard to tell who runs whom, essentially, the brain or the body. Human life, we're at the end, guys, we're at the end. Human life, the human physical form, including our beautiful faces, flat stomachs, dexterous hands, subtle humor, our complex behaviors, and our notable species achievements such as language, technology, and culture may be little more than ecological responses to the broader and more mundane economics of satisfying the dietary and ethological demands, the behavioral demands of a large brain. Some people laugh, when you mention the flat stomach, but, if you look at the belly of a chimp, you see a big distended belly, and it's simply because they don't have the short gut that humans have. These are things that are extremely Now, the other thing I want to say is, the whole insistence on aesthetics, okay, it's a cliche, but it bears mentioning that, as we know when we study mating behaviors, We know that it is through the senses that the fitness of a mating partner is discerned. Attractiveness, beauty, in a certain sense, is a sublimated and acculturated version of the appreciation of beauty. Well, what I really want to say here is this mating behavior and the discernment of attractiveness also is inseparable, I would say, from what we do. And in terms of the manipulation and production of forms, even those who are interested in ugliness, for example, are clearly tapping into these endowments, these ultimately nervous system endowments in our species. From this foundation, the entire human relationship to the environment was forever determined. Encephalization, one could argue, was not in itself driven by any need or desire to break off from the animal evolutionary tree in the direction of culture and language. That's bullshit. That's what I call, that's the East African school of Leakey, etc., who talks about this glorious emergence of the noble, peaceful human speed, the peaceful chimp, etc., who we now know is full of genocide thanks to the findings of Jane Goodall in the late 1980s. Anyway, it is actually the direct result of climate change and triggered by the invention of a novel cooling system, followed by the requirements of food procurement and the management of interspecies threats in a new ecological niche and in a new landscape. These latter forces imposed on us the need for ever more subtle ways of reading, remembering, and interacting with the environment with form, discovering ever new opportunities within it. This is a kind of sociobiology of form. I admit it, I'm guilty. I just want that to be said so we don't have any questions about that. If we are human, it is because this science, I would say, of the environment, empirical and intellectual combustion of our surrounding world was forced upon us, and it is the source of our very human genius for formal and technical innovation. Okay, now just a minute. The part that I said would make you happy. So I'll leave the talk off here. In the closing 90 seconds, I think what I need to do now is tell the sound guys that I'm going to play something with sound. In the closing 90 seconds, I'd like to present to you some images from an unusually remote tribal world in the Omo Valley. Some of you have probably seen these, of southern Ethiopia. Aside from the obvious lyrical beauty of the images and the social practices that they reveal, you can really read some, it's incredible stuff. One will see an uncanny demonstration of many of the themes presented in the last hour, in which social and corporal practices, body practices, extend seamlessly into the natural environment through a play of incorporation and annexation of the surrounding plant and animal world by a human group, of course, which is not unrelated to the practice of eating or of ingesting portions of the environment, nor to that of capture or hunting, nor even, for that matter, to evolution itself, because you could see evolution as essentially a way of combusting the environment continually, but which has, in the case I will show you, because we're humans, because they're massively encephalized species, been sublimated into symbolic, aesthetic, social, erotic, and even musical improvisatory activity through both crypsis, the use of that way in which a form finds a way to embed itself and make it invisible in its environment, and mimicry, and an undeniable echo of the somatic precognition that Kennedy described with respects to the Bushmen of the southern hemisphere, the way in which their body begins to feel the animal, the environment, the landscape, or become continuous with it. The landscape and the extended living world here is made to propagate over and through the body and to undergo continual transformation and communication. I want to insist, as we come to the last sentence in this presentation, in the process. It is perhaps, I would say, of some interest to some of you perhaps, to add of importance to add that it is said of these people that they do not possess, nor in many cases have they ever seen, as a rule, a mirror. Thank you. Thank you. Thanks for that. But I think what you're actually saying is, to what extent do we as a species continue to be subject to the forces that produced us, i.e., is evolution...
I agree with you. We are already that, and therefore everything we do is confirmed precisely by the arguments you would like to use to redirect us.
We are already...
What you just said, we are already a perfect expression of the forces that formed us, which means according to your argument, we are making no errors.
Things get really complicated once you have what is known as cortical plasticity. That's to say, the generalist framework becomes extraordinarily successful, but also very dangerous in terms of pure formulation. You cannot be very reductivist when it comes to that.
But I believe you made the most incredible case for monadic adequacy. The adequacy of a...
I know what you're thinking. I know what you're thinking,
And
yeah.
so, but I have one more question for you. I have tons and tons and tons of questions for you, but I'm serious about the orthodontist question. If the teeth and the tooth is as important as you express it is in terms of our mobility of forces and the degree to which they actually shape the brain, we should leave them alone.
I'm going to dodge your question and tell you a funny story I heard on the radio the other day. No, but it's fascinating because Martin Amis, the famous writer in England, I'm sure most people here have probably even read some of his novels, is being savagely criticized in the British tabloids because he went out and got himself, quote, a set of American teeth. The British can't deal with the fact that this guy's got a beautiful, set of ivories, and they just don't understand why you shouldn't have teeth rotting out of your head the way the rest of the Brits have. Pardon? Now, yeah, right. They're coming sideways, etc. No, it's a fascinating thing to go to England and just see the amazing lack of focus, if you like, on that particular aspect of hygiene, actually. But of course, what's interesting to note is the condition of teeth is unbelievably important factor in mate selection.
Like, by making everybody...
No doubt about it. Everybody gets to breed today. That's part of the democracy we live in. It's true. It's true. Some people assume that that has signaled the end of our evolutionary adventure. However, evolutionary theory, which I strongly encourage you all to look at, I mean, it is so diverse. There are so many axioms and So anyway, what we have discovered is that there is tons of evolution actually taking place today. It's not specifically focused on the issue of natural selection, because selection is not nearly as intense as it would be if we were allowing the environment actually to limit our capacities to mate. But in the scientists 8 or 10 years ago began studying microcephaly in Pakistan, actually, in Pakistani populations.
Be careful about that.
I'm sorry, yeah. But there's a region in Pakistan where you have an amazing profusion of pinheads being born, including 5 or 6 in the same family. So they went there to study it, and when they came up with it, they found that there was not, specifically speaking, a gene that selects, but there is actually an inhibitor which is present, the inhibition of a gene. There is an inhibitor which inhibits the expression of a gene for a large brain. And what they found upon subsequent study is that there is a new gene that is in 20% of the world population. And if your parents each had this gene, you're going to get one big damn head. But what they know is that the gene is only 150 years old, and it is making its way at a rapid pace through the human the population. We are actually being selected for even larger brains that we have right now, and there's no doubt that in 100 years, or possibly even in 3 or 4 generations, we're already going to see a mean increase in head size.
You know that gene is expressing itself by smell.
Wait a minute, first of all, do you know the gene?
Yes, of course.
You do.
But the thing that's really interesting is that its somatic expression is in your odor. So it gets selected for very heavily because it produces a...
I need to see this documentary that you saw on this, because
Anyway.
I haven't been able to follow up.
I'm going to go, but I know everybody wants to go to dinner, and I need a fucking drink so bad, it's unbelievable. But I got to say something...
So do I. How do you think I feel, man?
I got to say something in favor of also reading a little bit of architecture. If you read the evolution of architecture over the last 300 years, one thing you're going to learn is that the architects...
Now, you using the word evolution in a kind of colloquial way, or
Yes.
are you sort of...
Yeah. Pick a species that began. It's a fairly young species, and watch how it adapts to its environment according to the principles that you set
Oh, okay,
forth.
so we're looking at that aspect.
Okay. One of the things that you will find is that there was an intimacy in the self-conscious awareness of architecture as a high A discipline between the building and its environment that made architects the absolute last population in history to embrace air conditioning. They fought it every step of the way. They didn't want to do it. And so this idea that
Why did it affect the...
Yeah, because they thought natural cooling and natural ventilation, they were against it. And the thing that changed it was Jaws, the movie Jaws, and the success of the summer blockbuster, and the fact that it became code after that.
I thought it was the Vietnam War, but go ahead.
No. Air conditioning, no. I think air conditioning has been one of the most incredible events in the history of building in the world. It's changed economies all over the world.
And it's short-lived.
That's true, and it's anti-sustainable. But the one population of expert practices, monadic expert practices, that fought it tooth and nail to the point that Corb, Mies wrote against it, didn't want to do it, was forced against his will to use it at Olivetti, was architects. And I think if you read it a little bit, you wouldn't start your talk with a notion that one thing we don't do is pay attention to sustainability, which is how you began. You argued that not only we are not doing a good job, we don't have a history of doing a good job, we're the only fucking people on earth that did a good job.
Oh, wow. So you're basically telling us that particular development was actually a kind of, it was kind of a net progress. It was a net progress. I think the jury is hugely out on that.
Well, I'll finish y'all tomorrow.
Oh, well, oh, I see. Well, Jeff and I are going to dinner. We don't have to deal with this now. Anyone have any other stories to tell? I'd love to know about more documentaries out there. This is just a kind of a sum of. Listen, I got so many versions of this paper. It's true. Hippos and lions. We're talking about the development. These lions in the Lignanti. Is that what you're talking about? Jesus, did you see them? Did you see them? Ah, damn it. Yeah, one year I heard there were lions who developed a new way to hunt hippos, and that was they would jump on their backs and ride them for 2 or 3 miles across the savannas at night, and the hippos until the hippos just dropped of exhaustion, and then they would feast. Or the lions, who are so phobic of water, the hippos would make it back to the water hole, and the lions would take off and say, "Oh man, no dinner tonight." But the fact of the matter is, what was interesting about that, of course, was the fact that the lions taught the behaviors to their children, or to their kids, etc. Okay, that was a fascinating thing to see. I went there to see it. I didn't get to see it. I was out all night watching the hippos, and I never saw one of those attacks. I don't know if you did, but they have them online. YouTube happened. YouTube happened. This stuff is now, you can see all of it. Just punch in, I'm sure, hippos, lions riding hippos, and you'll just see this incredible. Of course, it happens at night. It's like, I don't know. By the way, there's an amazing video. Apparently, it's one of the most viewed videos on YouTube. This is so astounding. It is so primeval, it almost looks like it was made in Hollywood. But there's this astounding set of events where a lion pride separate a Cape buffalo baby from the rest of the herd, attack it, maul it, just absolutely start practically devouring it, but the baby's still fighting, and when they fall down the side of the thing, they fall into the river. Have you seen this? Absolutely amazing. Wait. No, you forgot the critical part. So the lions are all over this baby, right? They're all over this little baby who falls in the river, and, excuse me, but a fucking crocodile arrives and grabs the baby away from the lions. I mean, it's like something like Disney on drugs. And it starts like mauling and, just devouring this poor baby. And the lions say, "What the hell just happened? What did you do?" And they start yelling at each other and saying, "How did you let him go?" The lions say, "Come on, we can't let this happen." They go back into the water and they steal the baby back from the croc. And the croc is angry, and the croc comes up on land and wants to take on the lions. And the lions think, "Oh man, I can't believe we got our dinner back." And then you see the herd of buffalo. They say, "We're not standing for this." And they come back organized. Yeah, we're coming back for Junior. And they successfully take back, by an incredible coordinated set of actions. Yeah, man, it is like... Anyway, you guys got to understand, that was all dealt out in the evolutionary cards in some way. It's fantastic things, a crazy dance. So, any other questions? It's an argument for reading. Yeah, I think what Jeff was saying is fascinating, because not only do you read books, but it was also clearly a reading in the deeper sense. I mean, not in the deeper sense, but also the reading of form. What do we got happening here? Yeah.
Where's Lévi-Strauss?
Lévi-Strauss died 1.5 years ago, man. He's out of my face.
No, but the reason I ask is because Lévi-Strauss represents a productive collision of anthropology and architecture.
Is that so? That's interesting. What do you mean by that? Lévi-Strauss, let me tell you, fascinating character, but I don't. It was methodology that was his principal.
Now that he's gone, let me tell you what I mean. That not Lévi-Strauss himself, but the adoption and, in large part, misreading of Lévi-Strauss by architects in the 60s. If you go,
in
say...
the 60s?
Jenks and Baird, in their book Meaning in Architecture, that Lévi-Strauss actually brings communication to architecture. The architects reading Lévi-Strauss brings communication and information into architecture in the 60s and gives birth, strangely enough, to postmodernism. So one of the things that I would ask is, how much are we to look at the interaction of these fields in the way that you're looking at the interaction of ecologies? Because it seems to me that the sort of possible echo of some of those things would be something that we would want to have in our minds instead. First of all, what you say,
very, very interesting, what you're saying. But a distinction, you may not be too satisfied with this, but a very important distinction has to be made. There is Lévi-Strauss, who we know is an anthropologist and who studied especially the peoples of South America, various tribes and cultures in Brazil, as his subject matter. but there is principally the Lévi-Strauss as we inherited him, especially in architecture, in Anglo-Saxon culture, and essentially also in, French philosophy, structuralism, etc., which is Lévi-Strauss who brought linguistic method and a certain kind of systematic methodology to the study of the production of cultural meaning to us. And the Lévi-Strauss that you're discussing is essentially the linguistic methodology Lévi-Strauss. And it is not, for example, Lévi-Strauss's, specifically the analysis of the cultures of these tribes in South America. So you're asking an entirely different question, and it's a very interesting one. And I don't really know how to connect an answer to the things that we're discussing, that I'm discussing today to it, but. Yes, I knew this was going to happen. Now, how does he make his hair do that? Like, if I knew how to do that, that's how I would have come today. Now,
heard his lecture. Aren't we already there? I mean, aren't we already doing what you said?
now, it's. Do I see a Ghostbuster thing going on here? Oh, that is absolutely beautiful. That is.
We intuited exactly what you're saying.
When you had a lot of chiaroscuro going on before you brought it into the full light, I saw all kinds of things going on here. I'm very proud of Jeff. Jeff, thank you very much. We'll see him.